Our next speaker will be Arnaud Fontaine. Arnaud attained a BSc in Earth Sciences from Rennes University in France and an MSc in Economic Geology from Lorraine University, also in France. He was involved with the West African Exploration Initiative Program, looking at gold metallurgy. Current position, he's a PhD student at INRS in Quebec, in collaboration with Goldcorp, working on their Eleonore deposit and mine, and the Geological Survey of Canada.
Thanks again. I would like to thank also the organizing committee for inviting us to present this talk, and also along the review process for helping us, so thank Ken and CRC for that. I will point out the fact that there is many co-authors in this talk and associated with different government and also of Goldcorp Eleonore mines. So I would just point out the fact that thanks the exploration and the production department at the Eleonore mine for constructive discussion of what I would present here. And I also would like to thank Jean-François Ravenel, who did his PhD a few years ago on when Goldcorp acquired the project. And I would like to thank particularly Christine Bossolet, Nathalie Prudhomme, and Eric Fournier. And I also would like to point out that there is Jean Gauthier, who was a regional geologist who worked for 20 years in the James Bay area. And we have a lot of discussion of how the mapping program was important to exploration in those areas. So the title of the presentation is the Eleonore Gold Mine Exploration, Discovery and Understanding of an Emerging Gold District in Hayu East James Bay, Superior Province, Northern Quebec, Canada. I also would like to say that the discovery was made by Virginia Gold Mines 15 years ago, and I would like to thank Jean-François Ouellet, Michel Gauthier, and Mathieu Savard for discussion about the discovery, and some of the slides I will present are constructed by their team. Okay. So here's the focus of the talk. It's divided in several parts, and I will spend a little detail on, I will give you some details about the historical perspective of gold exploration in the area and how regional mapping program by the GSC and the Quebec government was important to targeting some areas. And after that, I will give you some of the important facts related to the discovery history. And after that, I will spend time to explain you the regional setting of the deposit and the deposit scale geology. And I will finish with some implication for exploration based on the geology also of selected adjacent showings located near the mines. I also would like to say that Goldcorp put a lot of effort to put in development and the mine sites. So the exploration program has been developed in the past 2 years. So what I will present you is a result of some of our exploration program in the area. So here's a map, a simplified map of the Superior Province, and as you can see here, the Eleonore is located northeast, in the northeast domain, far north from the known gold camps in Superior. In those areas, you have less greenstone belts, which are typical host rocks for origin gold deposits. And you have less high-grade metamorphic, more high-grade metamorphic rocks also in the area. And the Eleonore is located in those parts of the Superior. I just put some date here, and the map I will show you here, it's a map of Albert Peterlot from the Geological Survey of Canada. And he worked in those areas 120 years ago. And the interesting point is that he covered a large area in the northern Quebec, including the Eastman River domains, and it covered Precambrian volcanic rocks and sediments in those areas, and it discovered a gold showing called the Low Discovery. Oh, sorry, I just the boy. South of the Eleonore discovery here. And after that, 40 years after that, there is the Dome mines that explored in the same areas, and then discovered the Dome Rapids located south of the Eleonore discovery too. Between 1942 to 1964, there is some mapping with the Geological Survey of Canada. And in 1964, 1969, there is some exploration in the Eleonore property area, and Noranda discovered the gold copper showings located 15 kilometers south of the Eleonore mine site. After that, there is a series of different geological mapping programs by the Quebec government, and I will talk to you a little bit better on this. And in 2006-2008, there is more detailed geological maps that are also made in the Opinaka Reservoir, so close to the Eleonore mine site, compilation by the Ministry of Natural Resources and of Quebec. Here's a map of Michel Gauthier that shows you the different exploration program in the area. And one of the key facts is that after the discovery of the Amelot and the Musselwhite mines, targeting higher metamorphic rocks become more attractive. And also at the same time, in 1975, the Quebec government produced a geochemical survey of lake sediments, and more than 200 arsenic anomalies was identified in the place here. So that influenced a lot exploration targeting in those areas here. Here it's an isosurface of the metamorphic gradient. It was a regional scale criteria for gold exploration, and you are looking to the east here. And you can see a spatial relationship between the arsenic lake sediment geochemical survey anomalies here and the high metamorphic gradient. You have here a dot line here that we observe the spatial relationship between gold showings, and Helon is sitting right here. And we have the Opinaka, which is composed of migmatites and high metamorphic sedimentary rocks. And to the south, we have the Lagrange province, which is made of greenstone belt and scintillate tectonic intrusion. At this time, this was important because Michel Gauthier was working for Virginia Gold Mine at this time, and he decided to target in some of this area, so the area with high metamorphic gradients. Here's just a new lithotechnic map of the Quebec government, and I will just like to point out the fact that the contact between the two sub-provinces, it's the first metallotech for gold exploration in this area. And the contact was updated a lot because on the field is a progressive contact, so it's important to recognize that is an evolution of the mapping this contact and how important it is. Here's a map of the Opinaka Reservoir, and just to point out the key facts for discovery, you have here the transition zone to the Opinaka subprovince, so the migmatite terrain here. You have the L lake showing was discovered by Noranda mines in 1964, and Virginia Mal explored those area 15 years ago, and they found boulders here, and they found some similarities with Amelot mineralization. So they decide to explore the northern shorelines of the Opinaka Reservoir, and the Eleonore shaft is located here, so they found the deposit just here. So the key facts are the discovery boulder near L lake showing, the systematic prospection of boulders, and also tracing the transition through migmatites. They also perform some mobile metal ion survey, soil horizon B survey, and extensive geophysical survey. I will just show you one example of this survey here. It's a magnetic survey with 50 line spacing grid, and they help us to define the contact between the L lake intrusions and the metasediments around this. You have here gold, copper, silver occurrences here, and when they map the northern shoreline, they were able to trace the contact with the metasediments, and they found some gold occurrences here in a fault closure made by this intrusion here. So they found gold, arsenic, antimony anomalies here close to the mine site. Here's just a photograph of what it looks like on the field. You have the L Lake showing located 15 kilometers south of the discovery area. And the 50-50 zone is a replacement zone with stockwork of veinlets that return 15 to 20 ppm of gold over 10 to 15 meters. You have a photograph here of the team of STG and Virginia mines that discover this place here. You have the host rock is a thinly bladed walkie, and this is interesting also because the age is maximum age of 2675 million years, so it's quite similar to the Timiskaming group in the Abitibi subprovince. And I have to say also that a lot of uranium blade geochronology was made by the geological survey on the area, and it's helped to constrain the stratigraphic contacts and lithologies that host the gold mineralization. I will went through this after that. Here's an outcrop. It's 400 meters outcrops, and you have some of the first intersection here beneath the 50-50 zone and the 6000 zone. That differs in terms of mineralization styles, and you have also the location of the Virginia Discovery Trench. So the trench are located right on these two zones here. So the zones are mined at the moment. So Virginia Gold Mine discovered the world-class gold deposits in an underexplored and not well understood areas. And I will focus now to 4 points. And they are based on the knowledge that we have on the geology of the mine, the structural complexity, and how we can integrate this in regional targeting. And also I will discuss a little bit on geochemical data and geophysical data to help us to better constrain the geology and targeting some areas. And I will finish with some gold showing in the area and some of the new discoveries by Serious Resources and Azimuth, which are junior company located just south to the Eleonore property. So here, just a map, a surface geology of the mine. You have the shaft. Here's the production shaft and the exploration shaft here. The zones are located in fold closure. You have a complex tubulitic sequence with aluminosilicate-rich peelite here, and all zones are located in the thinly bedded walkie, which is the youngest sedimentary unit in the area. I would also like to point out the fact that the migmatite transition is close. It's located 1.5 kilometers northeast of the shaft. I have another slide that just to show you how the geometry of the zone here, and it's important to recognize that the zones are located at along the contact between two distinct sequences, youngest one to the west and an oldest to the east. And this is really important for exploration because we know that these contacts are folded by a series of isoclonal folds related to the main deformation. And we have also some east-west trending zones that are axial planar to the F2 folds. So we try to integrate this, and we also did some map of the drift to integrate the complex geometries that we have here. Here at east-west section view to just to show you the mineralized panels. So we have a good vertical continuity. And we also use this section to integrate the hydrothermal footprints of the deposits. So you have some point here which represents the potassium and sodium ratio. And we use this because of the replacement zone alterations that are made of the microcline replacement zone associated with. And we use this also to perform a later geochemical program with more than 1,000 points to integrate the hydrothermal footprint of the deposit I will discuss after. So it's an example of a grab sample that show you how the ore is deformed. You have a quartz dioxide vein with diorite veinlet, and you have the replacement zone I just talked before. We just point out the fact that you have composite grain most of the time, and the lolangite, which is an iron arsenide, contains the most of the gold here. And it's interesting because we also perform some laser ablation ICP-MS to constrain the metallic signatures, and it gave us an arsenic antimony. Selenium, bismuth, tellurium, metallic signatures that we use in our geochemical data to targeting some area in the property. So when we do prospection in the James Bay, we have poor area of outcrop exposure. We have something like 4% of outcrop on the Eleonore property, and 60% of the property is just lakes. And we have a lot of blocks, so we try to integrate this information in targeting those areas. So here is an example of what we have in terms of geochemical data. We have lake bottom sediment, till boulders, and also soil geochemical survey. And we use that to targeting some area. I just would like to point out that the Horizon B survey and I don't have a point, but the Horizon B survey was made by Virginia Mines, and you have here the anomalies that are made by the mine and by the mineralization of the Roberto deposit here. So this was critical in the discovery also for the Virginia teams. We also use a geophysical survey. Here is just to point out the fact that we separate our lithologies into a major domain based on the magnetic intensity. So we have low magnetic represented by diorite, granodiorite, tunnelite, and pegmatite domains. I will show you just after that an updated map of the district. We have heterogeneous height and low mag, which are mainly turbidity wacky domains with a lot of variety of sedimentary types. And we have highly mags, which is a conglomerate, which is located just here. So we have a conglomerate at the base of the sequence. We have the intrusions located here, and you have the turbidity sequence that hosts the Eleonore mines here. We use also the first derivative of the magnetic field to integrate the structural features, and as we observe the complexity in the Eleonore mine site, we try to targeting specific areas. And as I said before, we know that the gold mineralization are in place in D1 structures and affected by the D2 deformation. So we try to integrate this in our exploration program and targeting some F2 closures. And here's an interpretation of the first derivative maps. And that helps us to constrain an area that are located directly to the south of the magmatic domains. And as you can see, the yellow stars are gold showings actually worked in the area. So you have the Chichu monies, which is Chichu, which is part of the Chichu property. You have the Eleonore, which is a joint venture between Eastmain, Goldcorp, and Azimut. And I will talk a little bit on this after that. And you have the Sini, El Lake, and Mayapo, which is some targets that I will discuss a little bit. I don't have a lot of time. So I just here an updated map that show you the interpretation that we have now. We have a series of different intrusions, various composition, and the white units are the walkie, which is a tubitic sequence. And we are interested in two areas now, the Sini area and the Chichumoni area. I will just give you more detail about that. The Sini area was found after some anomalous boulders that are found in this part here. So we have a lot of gold anomalous boulders here, and we also performed a magnetic survey here last year. And this is interesting because we found the same structural complexity. We found a fault closure here. We have an iron formation, and we think that it can be the source of the anomalous boulder here. We have also a pyrognous unit here that have been found in boulder here. So we found some similarities with Musselwhite mine, so we tried to integrate this and we work on this probably in first year. So. Also, one of the things I would like to point out is the tonalitic gonadotic intrusions are located directly to the south, and we date them, and we have an age of 2612 million years. So it's interesting because we have the same age at Eleonore for the pegmatite dikes, and most of the pegmatite dikes cut the ore. So it was interesting because the Chichu discovery, the Moni discovery are located in this domain here. Okay, I'm running late, so I will go fast. Right? Here's an example of the mineralization at Chichu. You have auriferous chitate vein array with quartz feldspar veins, and you have arsenopyrite pyrrhotite vein and a lot of visible gold associated with. You have quite the same mineralization in the Moniz prospect located 5 kilometers west of this, but the interesting point here is that you have a great continuity, and also the showing are located within the tonalite, not only at the contact between the metasediment and the intrusion. So what did we learn with all of that? Because passing through some of the aspects in terms of geology and geochemical and geophysical data, we think that there is, in terms of exploration and discovery, Virginia Gold Mine discovered a world-class gold deposit in the under-explored and poorly understood area. So there's an importance of geological mapping program and also geochemical survey of lake bottom sediment to targeting arsenic anomalies in those areas. There's a systematic prospection around historical showing, including sampling of erratic boulders, glacial flow direction to track sources of gold-bearing wands. There is some extensive geophysics made by Virginia Gold Mines, and we use this for structural interpretation. And in terms of understanding, we think that there is a long-lived gold-bearing hydrothermal activities associated with regional metamorphism, deformation, and also the importance of British magmatism are questioned for them. We have also polyphase deformation recorded by sedimentary rocks next to a major tectonic contact near the magmatic domains. And the gold showing shares strong analogy with hypothesal orogenic gold deposit and reduced intrusion-related system. I'm running out of time, but I will finish with this. And in terms of exploration target, I will just put some points that appears to be important in terms of exploration targeting. So the structural timing of gold mineralization, the importance of alteration halos, the total magnetite field, the IP and VTM survey. I will not have time to discuss this, so sorry for that, but you will find more detail about the geological complexity and also how we use this technique in the article if you want to learn more about that. I think I will leave with that, so sorry for the delay.
Thank you very much.